Hello, this is section 3.1. We're going to be talking about functions. Now, just like before, at any point, if you want to pause the video and, for example, try the examples on your own, please do so. It's excellent practice. And if, I'm going too fast, then just pause it and continue when you're done with yours. Okay, we're going to be talking about functions here. We have two different ways to kind of say what a function is. We have an informal and a formal. So informally, a relation for which each input corresponds to only one output. And formally, a relation for which each element in the domain corresponds to only one element in the range. Now, so we have input and domain. Again, input is the informal way of saying it. Domain is the formal way of saying it. Both of these are the x values. For the output and range, they are y values. And now a kind of a trick to remember. I comes before O in alphabet, D comes before R in alphabet, and X comes before Y in alphabet. So um, kind of looking at the alphabetical order, we can, if you can't remember that input, domain, and X are together. Okay, when we are trying to figure out if a relation is a function, from a graph, we use a vertical line test. And a relation is a function if a vertical line is drawn and touches the graph only once for every x value. So let's look at the graph of a company's monthly revenue. What is the revenue when 36,000 phones are sold? So we've got the cell phones on the x-axis, and we've got the millions of dollars on the y-axis. Now, they've already marked the 36,000 here. Um, so when we go up, we can see that it actually, there's 2 points where we've got the 36,000 as the input. Now, for us to figure out what is the revenue, we're going to go ahead and see where we end up on the y-axis. So it's between 1 and 2. It's very close to 1. I would say that it's 1.2 million. So $1.2 million. Or the other one here, same thing. It's between 2 and 3. So I would say that it's about 2.8. So $2.8 million. Now, a question, is this a function? Well, with the vertical line, it crosses at 2 points. So this is not a function. It is a relation still, but not a function. Okay, let's move on. Determine if each relation is a function. So the first two are graphs. So those we're going to just draw vertical lines here and look at, okay, well, all the vertical lines touch only in one point. So this is a function. With the next graph, we have, again, we're drawing the vertical lines, but here we can see that the graph touches the vertical line in 2 points. So this is not a function. Next, we have tables. So what we're looking for is that our x value is not, the same x value is not listed twice with a different y value. So if we look at the first one, we've got 1, 2, 3, and 2. Well, we've got 2 listed twice, and one y value is 8 and the other one is 10. That cannot be a function. We can't have a different y value for the same x value. Okay, the next one is one 2, 3, 4 are the x values, and our y values are all different as well, which really doesn't matter. But this is a function because there's no, or the outputs are all different. Next one, again, we're looking at the x values, 1, 2, 3, and 4. They're all different. It doesn't matter even though the y has the two negative 2's. The input can be, we could have the same input, or I'm sorry, the same output on each one. So we could have the same y value for all of these x's. It's just that the x's have to be all different. So 1, 2, 3, and 4. So this is a function. Okay. Now, when we are finding the domain of a relation, typically there are no restrictions, which means that it would be all real numbers, so negative infinity to infinity. That's just two different ways of writing it. But we do need to ask ourselves, do I have any values which make the function undefined? So that is, do I need to exclude anything from the domain? Well, if we think about, for example, a rational function, denominator cannot equal 0. Or if we have a square root, it cannot be less than or equal to 0. So our denominator cannot be a 0 because we can't divide by a 0. That is undefined. Square root um, has to be greater than 0. Or it can be equal to 0 as well. Okay, so let's determine the domain of each relation, and is it a function? Um, we're only finding the domain. Now, what we need to do is we need to look at the square root and look at what's under. Excuse me. So the square root cannot be a negative. So what that means is 5 minus x has to be greater or equal to x. So now we're going to solve for x. We are subtracting 5 from both. So we get negative x is greater than or equal to negative 5. Let me just put lines here so that I'm not using all the space. And then we are dividing by negative 1. Now remember, we're dividing by a negative number. So that means that we flip the sign. So x is less than or equal to 5. So this is our domain. Another way of writing it, so x is less than or equal to 5, would be negative infinity to 5. Now, is this a function? If we think about the x values, we're going to have one x value for each y value. So yes, it is a function. Okay, let's move on to this next one here. Y equals x to the power of 4 plus 3. Are there any restrictions? Are we dividing by a number or by x? No, we're not. So that's not, we don't have to look at the denominator. And we don't have a square root. So for this one, it is going to be all real numbers, so negative infinity to infinity. And is this a function? Yes, it is a function. Because for all the, like we could plug in x and we would just get one y value for each x. Let me just circle this so that it's clearly there. Okay, next one. Y equals x plus 5 divided by x minus 2. Now, for the top, the numerator, we don't have to worry about that. There's no restrictions on that. X minus 2, the denominator, we do have restrictions. So that cannot equal 0. So we're just going to set it to not equal 0. We're adding the 2 to both sides. So x cannot equal 2. So this is a restriction on here. Now, So what does our domain look like? We start from negative infinity and we have to exclude 2. So we're going to put 2 inside parentheses, and then we continue from the other side of 2 to infinity. So this right here means that we excluded 2 because it cannot be a 2. That would set the denominator to become a 0. And this is still a function because if we plug in x's, it's just going to give us a 1 y. Okay, next one, y equals 1 over x squared minus 4. Now, again, we cannot, the denominator cannot be equal to 0, so we are going to have to say x squared minus 4 does not equal 0 and solve. So x squared, we add 4, we get x squared equals 4. Now, the opposite of x squared is a square root. When we take a square root, we have to add a plus and minus because that we can have a plus and minus answer. X equals positive and negative. Square root of 4 is 2. So this is because if we do negative 2 squared, that is 4. If we do 2 squared, that is 4 also. So that's why we have the 2 that we're ruling out. So x cannot equal negative or positive 2. So what is the domain for this function? It would be negative infinity to negative 2, negative 2 to 2, and 2 to infinity. So there's um, three parts to it because we need to exclude the negative 2 and we need to exclude 2. And this is still a function. Even if we plug in what numbers for x, we're going to only get 1y. Okay, next part. Function notation, f of x equals y. Um, so this is the same thing. F of x is y. So we could write, for example, we're used to seeing y equals 2x minus 1. Well, this is the same thing as f of a function of x equals 2x minus 1. So on this next one, we're gonna we have a function f of x equals x squared plus 3. We're gonna evaluate it with the whatever we're given here. So our first one is f of 1. So this means that instead of x, we have a 1. So when we're writing the function, we're gonna plug in the 1 where the x is. So 1 squared plus 3. 1 plus 3 is 4. Next one, f of negative 1. So again, we're plugging where x is, the negative 1. So negative 1 squared plus 3. Now, parentheses are important here because negative 1, when negative 1 is the base, um, it's negative 1 times negative 1. So two negatives become a positive. So it is a 1 plus 3, which is 4. Now, if we leave the parentheses out, if we write it like this means negative 1 times 1 squared. So this answer would be negative 1. So notice the difference. The base is only the 1 in this case. When we write it inside parentheses, our base is this whole thing that's in here. So it's negative 1 times negative 1, which is a 1. So be careful with that. Okay, next one. Here, f of a. So again, we have a instead of the x. So we're going to plug in a, where x is a squared plus 3. And that's it. We can't simplify it any farther, so that's our answer. Now, this next one, we have a plus 3. So again, we need to be careful with those parentheses. So a plus 3 is the whole um, base. So all of that needs to be squared and then add it 3. Now, we this thing here is the same thing as a plus 3 times a plus 3. So we're going to FOIL. First is a squared, a times a, outer a times 3, so I'm just going to write it 3a, inner 3 times a, last 3 times 3, which is 9, and then we have the 3. So our answer, combining like terms, a squared plus 6a plus 12. So again, make sure that you're careful with those parentheses. Okay, let's move on to an application. The mean age of a woman in the United States when her first child is born can be approximated by the function f of x equals 21x to the power of 0.0565, where x equals 10 corresponds to the year 2010. Estimate the mean age of a woman at the birth of her first child in the following years. Round your answers to one decimal. So 2010. So we were already told that year 2010 is the same as x equals 10. So f of 10 equals 21 times 10 to the power of 0.0565. Now, when we plug this in the calculator, we get 23.9 years. Let me actually make sure that we are how we're rounding it. I'm just looking at my key and not doing the calculations. 21 times 10 to the power of 0.0565. Nope, and I made a mistake. Okay, so this answer is 23.91769. So we're rounding it to the to one decimal. Now, 9, we look at the number to the right of it, and since this is less than 5, the 9 doesn't round up. So our answer would be 23.9 years. Okay, let's look at 12. So that is 12 years after. So f of 12 is what we're calculating here. So 21 times 12 to the power of 0.565. When we plug this in the calculator, we get 24.1653. Now, again, one decimal, the number to the right is 6, which is greater than 5, so we are rounding it 24.2 years. Okay, our third one is f of 14. So 21 times 14 to the power of 0.0565. 14 to the power of 0.0565. 24.3767. And now, again, rounding it to the first decimal, 7 is greater than 5, so we need to round it to 24.4 years. Now we have a question here. Is the average age increasing or decreasing? Well, we go from 23.9 to 24.2 to 24.4, so it is increasing. Okay, next we're going to look at the difference quotient. It gives the average rate of change between 2 points. Um, so we have a point x and f of x, and then we go the distance of h. So we add h to the x, and we add h to the y value, or we add the h to the x, and then we plug it in the y. So the difference quotient is f of x plus h minus f of x over h. Okay, so now we're gonna go ahead and um, find the difference quotient for each of these functions. So we're using this right here. Um, and plugging it in. Um, okay, let me just make a little square here so that I don't go over too bad. Okay, f of x equals 3x plus 2. So what we're going to do is we're going to write, so that is our f of x. Our f of x plus h is going to be 3 times x plus h plus 2. So see how instead of the x, I wrote the x plus h here. Okay, so let's write the difference quotient. So we're going to write the f of x plus h, which is this part here. So 3 times x plus h plus 2. Then we are subtracting the f of x from it. So f of x is this, 3x plus 2 inside parentheses because we are subtracting. Then we divide this whole thing by h. So now we need to distribute um, 3x plus 3h plus 2, um, and then distribute the negative, so switching the signs over here, still dividing by h. Now, we have a plus 2 and a minus 2, so those cancel out. We have a 3x and we have a negative 3x or a minus 3x, so those cancel out. We end up with 3h over h. The h's cancel out, and we have a 3. So our difference quotient for f of x equals 3x plus 2 would be 3. G of x equals x squared plus 1. So the same thing, this is our g of x. Now our g x plus h would be x plus h squared plus 1. Um, so you have the option of foiling it here or foiling it once you have it inside the difference quotient. A lot of times you don't necessarily need to write this step down. You can just go ahead and do the difference quotient immediately. So I'm just going to write the g of x of h. Remember that that comes first on here. So x plus h squared plus 1 minus our g of x, which is x squared plus 1 inside parentheses, and all this divided by h. Okay, so now this x plus h squared, there's two ways. We can FOIL it, or there is a formula for it, which gives us x squared plus 2 times x times h, so 2xh plus h squared. Then we have the plus 1, and then we distribute the negative x squared minus 1. Again, I took a shortcut for this part here. So if you need to FOIL it, go ahead and FOIL it. That is totally fine. And we divide the whole thing with h. We have x squared and we have negative x squared. So those cancel out. We have a 1 and we have a negative 1. So those cancel out. So what do we have left? 2xh plus h squared over h. Now what we can do is we can, both of these have an h, so we can take out an h from there. I have 2x left after I take out the h, and then I have 1h since I've got h squared over here. So what I did was the opposite of distributing. I could go back and distribute this, and I would get this same answer, 2xh plus h squared here. The reason why we did it is because we are dividing by h, so these h's cancel out, and we get 2x plus h as our answer for the difference question. Okay. We've got one more difference quotient that we're going to practice. And again, you can always pause it and try it on your own. So our h of x plus h here would be x plus h squared minus 2 times x plus h. And our difference quotient is h, x plus h. I did not do this with the other ones, but I'm going to write it here because we can't see the difference quotient on the above it. Okay, now I'm going to plug in my x of x plus h, which is this whole thing right here. So x plus h squared minus 2 times x plus h. Then I'm subtracting the h of x, which is this part right here. So minus x squared minus 2x inside parentheses, dividing this whole thing by h. So again, this right here, h of x, is this right here. And h of x plus h, we did it over here, so it's this first part right here. All right, now we need to start distributing. Again, x plus h squared, you could FOIL x plus h times x plus h. I'm going to use the quicker way. So the formula. Next, we need to distribute the negative 2 inside the parentheses. So negative 2x minus 2h. Same thing here, distributing the negative x squared plus 2x. And all this is divided by h. Okay, let's look if we can cancel something out here. We have a negative x squared and an x squared. We have a negative 2x and we have a positive 2x. I think that's all we can cancel. Let's see. So what do we have? We have 2x times h plus h squared minus 2h divided by 2. Not 2, divided by h. Yes. Now we can take out, each one of these has an h, so we can take out an h. So the first one is left with 2x plus h minus 2 divided by h, and the h's cancel out because there's one on the numerator and one on the denominator. So we get 2x plus h minus 2. I'm going to rewrite it in alphabetical order like this, and there's the answer. This requires work, and again, like I said, this part here, hold on, this x plus h squared, let me see, x plus h squared is the same as x plus h times x plus h, and you just FOIL it. and you would get x squared plus xh plus xh plus h squared, and then we combine these two. And we end up with the same answer as I did with the shortcut here. Um, I just used the formula. Okay, next one is going to be operations on function. So operations, they're familiar operations, sum, difference, product, quotient. So basically it's the exact same thing. F plus g of x is f of x plus g of x. F minus g of x is f of x minus g of x. Product f of g of x is f of x times g of x. And quotient f divided by g of x equals f of x over g of x, where g of x cannot equal 0. Remember that part, that we cannot divide by 0. So consider the given functions to evaluate the operations that follow. So we have a f of x and we have a g of x. Okay, so what we're going to do here. So f plus g of 1, this is the same thing as f of 1 plus g of 1. Now, as you see, all of these have 1s. So what we're actually going to do on the side here is we're going to evaluate f of 1 here. So we're plugging in the x. 2 times 1 squared plus 3 times 1 plus 1. So 2 plus 3 plus 1 is going to be a 6. For g of 1, we get 3 times 1 squared minus 4. So 3 minus 4 equals negative 1. So now what we can do is we calculated the f of 1 and g of 1, so we can just go ahead and plug it in. So our f of 1 is 6, and then our g of 1 is negative 1. So when we do this calculation, 6 minus 1 is 5. This makes it just a little bit easier. We could have plugged it in all. So what we could have done is um, or added, we could have added this part and this part, not all the way to the other side of the equal sign. Um, and we would get the exact same answer, 5. It just makes it easier if we have the f of 1 and g of 1 already calculated. Okay, next one is f times g of 1. So that means f of 1 times g of 1. Actually, you know what? Let me use the colors that I did use. Oops, it did not erase everything. Still not erase everything. Here we go. Okay, so f of 1 times g of 1. So this is our f of 1 is 6, and our g of 1 is negative 1. So our answer is negative 6. Okay, next one. What? Next one is f minus g of 1. So it is f of 1 minus g of 1. And again, we did the calculations here. We have a 6 and a negative 1. So 6 minus negative 1. That is 6 plus 1, which is 7. So again, we could have done this so that we do the f of 1. So our f of x is 2x squared plus 3x. So 2 times 1 squared plus 3 times 1 plus 1 minus, because we are subtracting here, g of 1 inside parentheses. So g of x is this, 3 times 1 squared minus 4 inside parentheses. And then do the calculations. So 1 squared is 1, 2 plus 3 plus 1 minus 1 squared is 1 times 3 is 3. 3 minus 4 is negative 1. This becomes a negative, and a negative become a positive. So 2 plus 3 plus 1 plus 1, 5, 6, 7. So the same answer if we do it from scratch or if we do it with the f of n and g of n. Okay, we've got one more here. We have the quotient f divided by g of 1. So f of 1 divided by g of 1. Now, we already have those calculated. F of 1 is 6, and g of 1 is negative 1. So our answer here is negative 6. All right, we're going to go and look at an application here. Um, A department store has two locations in a city. From 2008 through 2012, the profits for each of the store's two branches are modeled by the functions f of x equals negative 0.44x plus 13.662 and g of x equals 0.51x plus 11.4. So f of x and g of x. In each model, X represents the number of years after 2008, and F and G represent the profit in millions of dollars. Okay, first thing is, what is the slope of F? So the slope of F is the coefficient of the X, so the one number in front. So remember, Y equals mx plus b, b, not h, and m is the slope. So it is negative 0.44. Now, it is a negative slope, so that means that it is going downhill. And it's asking describe what this means. Well, because it's a negative, it means that they are losing dollars. Now, looking at what is the slope of g, that is the same thing. Is it the number in front of the x? So 0.51, that's a positive slope. So they are making dollars. Next, it's asking us to find f plus g. So f of x plus g of x. F of x is negative 0.44x plus 13.62, and then we are adding g of x to it, which is 0.51x plus 11.4. Okay, now we're going to combine like terms. So 0.44x and 0.51x, that adds up to 0.07x, and then 13.62 plus 11.4 equals 25.02. So what is our slope? Again, our slope is this number in front of the x, the coefficient. So slope is 0.07. So what does this mean? It means that they are making dollars. It is a positive slope. So They are making dollars here. Okay, one more. Oopsie, that was not what I meant. One more here, which is the composition of functions. So the composition of the function f with g is denoted like this and is defined by the equation. Um, Now, notice that the little circle here, it really means that the one that is after it, so the g of x is inside. The first one function is the one that's outside. Okay, so let's look at, we have f of x equals the square root of x, and then we have g of x equals x squared plus 1. Oops, I didn't mean to write it on top of the other one. Here we go. Okay, so this right here, the f of g of x. Let me draw some lines here. This is the same thing as f of g of x. So what this means is that we're going to take the f of x and we're going to plug in g of x, which is this right here, inside our f of x. So our f um, so f of, and our g of x is x squared plus 1. So this is what we're plugging in the f of x now. So f of x is the square root, so it's going to be a square root of g of x, which is x squared plus 1. And that's our answer. So now let's look at what happens when we flip it around. So now on this next example, the g is the outside and f is the inside. So what does this mean? It's going to be g of square root of x because our f of x is the square root. Okay, so we're plugging it in. We have a square root of x to the power of 2 because of the x squared plus 1. So the square root and the squared cancel each other out, and we get x plus 1 as the answer. So notice how these two answers are totally different. This one has the square root, and this one doesn't because the square root and the squared cancel out. So depending on which function is inside and which one is outside, we get a different answer. Okay, let's look at now this next one. So we have f of g of 2. So what we need to do first is we need to calculate, well, so actually, never mind, ignore what I just said. We did calculate f of g. So we have this here with the x. So what we can do, since we already did it, we can just go ahead and plug it in. So we have square root of 2 squared plus 1. So remember the 2 goes where the x is. So 2 squared is 4 plus 1. This would be square root of 5. So because we already had it, we can do it that way. The other way of doing it would be that we calculate our g of x first, or g of 2 first, I'm sorry. So g of 2 would be, again, g of x is x squared plus 1, so 2 squared plus 1, which is 5. And then we plug it in the f. So f of 5, so this 5 goes into the f, and our f of x is a square root of 5, like that. So the same answer depending on, which way you are doing it. So there were two ways that we did it. This was the first way, and then we did it the second way. Okay, so the same thing over here, where we have g of f of 2. Again, the g is outside, the f is inside. And now what we can do is we can take straight this that we got the answer. So we can just plug it in here. Instead of the x, we're going to use the 2. So 2 plus 1 equals 3. And that's it. Now, the other way of doing it would be to first calculate f of 2, which is the square root of 2, like that. Then we would plug that in to g. So g of square root of 2 right here. So square root of 2 squared plus 1. Again, the square root and the squared cancel each other out. So it's 2 plus 1 equals 3. Again, same answer. So there, I showed for 3 and 4, I showed two different ways how to do it. This was number 1, and here's number 2. Okay, let's look at an application as our last example here. Um, the regular price of a computer is x dollars. Let f of x equal x minus 400 and g of x equal 0.75x. Now we are supposed to find f of 1,000. Are you taking a $400 discount or a 25% discount? So let's see. We are f of 1,000. We're going to take our f of x and plug the 1,000 in where the x is. So 1,000 minus 400, which is 600. And again, these are all prices, so these should all have dollar signs. Okay, so what did we just do? We had $1,000 computer. We subtracted $400. So we took a $400 discount, right? Okay, let's look at g of 1,000 now. What are we doing there? So here's g of x. So 0.75 times 1,000 is going to be 750. Again, these are all dollars. So what did we just do? 0.75, that would mean if we take 100 and subtract 0.75 from it, we would get not 100, 0.75, we get 0.25 as our answer, which is the same thing as 25%. This is the, not 25 also, 75%. So we are, since the amount that we are multiplying it by is the 75%, we are doing a 25% discount on it. Okay, next, we have f of g of 1,000. And as you can see, I like to write it this way. It shows me what goes inside first. So we had g of 1,000. We just did it over here. So we're going to do f of the $750 right here. That was our g of 1,000, which is here. And now we're going to plug it into the f So $750 minus $400. And that gives us $350 right here. So this is when we took the 25% discount first because we had the G of 1000. Now, next one, we're going to find G of F of 1000. Again, we already have the F of 1000 calculated over here, which is the 6000. So what all we're going to do is we're going to do G of $600. And now we're plugging it into our G of X here, which is 0.75 times the 600. And when we do that calculation, we get $450. So in this case, we took the $400 discount first and then the 25% discount. Okay, next, which order favors you? So if you're the buyer, which order would you like to do? If we look at the prices, $350 is less. So F of G favors the customer. Now, what about favors the store? It's the $450 because that's a higher price that the customer is paying. So it would be the other order that favors the store first. Okay, well, that's it for lesson 3.1. Again, please don't hesitate to email me or ask me if you have any questions on this lesson. Bye.